You know, we're often taught a lot of separate facts about our planet. But today, we're going to do something a little different. We're going to look for the hidden connections, the secret handshakes between volcanoes and weather, mountains and rivers. We're going to see the Earth for what it really is, one giant, interconnected system.
So, let's start with a question that sounds a bit like a riddle. What connects a volcano erupting in the middle of the ocean to the weather right outside your window? It's not a trick question, I promise. The answer is all about understanding the deep, powerful forces that link everything from the planet's molten core to the very air we breathe. This is what we're digging into today, how all the pieces actually fit together.
To get our heads around this huge, single system, we first need to know what the main parts are. Think of our planet as having four fundamental components that are in a constant conversation with each other. Let's break down what they are.
Okay, so imagine the Earth has these four massive interacting layers. First, you've got the lithosphere. That's all the solid stuff, the rock and the crust right under our feet. Then there's the hydrosphere, every single drop of water, from oceans and rivers to the ice caps. Wrapping around all of that is the atmosphere, that surprisingly thin blanket of air. And woven through every part of it is the biosphere. That's us and all other life. And here's the key. None of these operates on its own. They're all tangled up.
So what's making them interact? What's the driving force behind it all? Well, the story starts deep, deep inside the planet. It's powered by these incredible internal forces, what you could call Earth's heat engine. This is where the most dramatic changes we see on the surface get their start.
If we could slice the Earth open, we'd see we're living on the crust, which is really just this paper-thin layer of rock. Below us is the mantle, this huge, thick layer of semi-molten rock. And right at the center is the core, a super hot, dense ball of metal. Now, what's absolutely crucial to get is that the insane amount of heat radiating from that core is what drives almost all the movement on the surface. That's the ultimate power source.
That heat gets the tectonic plates, the broken up pieces of the crust, moving around. And where these plates meet, that's where the action is. At convergent boundaries, you've got plates that are colliding, crashing into each other, creating immense pressure. Then at divergent boundaries, they're pulling apart, which lets new material from the mantle come up and create brand new crust. These boundaries are literally where the Earth is actively building and rebuilding itself.
So what does this actually look like in the real world? Well, just look at the Himalayas. You've got the Indo-Australian plate crashing into the Eurasian plate in what has to be the world's slowest car crash. The pressure is so intense, the crust has nowhere to go but up. It just buckles and folds like a rumpled carpet. That is exactly how the tallest mountains on Earth were built. And hey, they're still growing today.
All right, so the Earth's internal engine is busy building these giant structures. But as soon as they're built, a whole other set of forces immediately gets to work tearing them down. These are the external or exogenic forces. You can think of them as the planet's artists, constantly carving and sculpting the surface. And this right here is the central drama of physical geography. It's this constant tension. You have these internal forces pushing land up, creating mountains and volcanoes. And at the exact same time, you have external forces, wind, water, ice, working tirelessly to wear them back down. This dynamic battle is what creates all the amazing and varied landscapes we see around us.
So who are these sculptors? Well, you've got wind, which can literally sandblast rock into incredible shapes. You've got massive glaciers that can scour out entire valleys. And of course, sea waves that just relentlessly pound away at coastlines. But the most widespread and powerful agent of all is running water. Give it enough time, we're talking millions of years, and a simple river can carve out something as mind-bogglingly vast as the Grand Canyon, just one grain of sand at a time.
Okay, so we've got the forces building the land and the forces carving it. But what about the fluids that are all around it? The air and the water? Well, they form this massive climate machine, and it's constantly moving energy and moisture all around the globe, shaping climates and making life possible.
The air we're all breathing is actually a really specific mix. It's mostly nitrogen, and then there's about 21% oxygen, the stuff we need to survive, plus a tiny little bit of other gases. This precise recipe is perfect. It traps just the right amount of heat, it drives our weather, and it protects us from nasty solar radiation. If you change this mix even a tiny bit, the whole climate machine starts to behave differently.
Now, try to think of the oceans not as still pools of water, but as having these massive rivers flowing inside them. You have warm currents, like the Gulf Stream, carrying tropical heat north. It's the whole reason Western Europe is so much milder than parts of Canada at the same latitude. At the same time, you have cold currents, bringing nutrient-rich water up from the poles, creating some of the best fishing grounds in the world. These currents are working 24/7 to regulate temperature on a global scale.
This conveyor belt metaphor is just perfect. Without it, the tropics would be unbelievably hot, and the higher latitudes would be pretty much locked in a permanent deep freeze. This constant circulation of water is what moderates the entire planet's climate, and it's what makes huge parts of the world livable. It's a critical piece of the puzzle. So we've looked at these different systems in pieces, right? The internal engine, the external sculptors, the climate machine. But the real magic, the big aha moment, happens when you see how they all plug into each other. Let's trace one single powerful chain of events to really see this grand design in action.
This right here is the key takeaway for today. Just follow this causal chain. It starts with a tectonic collision. That's pure geology. That collision creates the Himalayas. Okay, now this massive mountain range blocks and redirects air currents, which in turn creates the seasonal monsoon rains. Those rains feed enormous rivers, which carry sediment down from the mountains, depositing it and creating these vast, incredibly fertile plains. And what happens on fertile plains? They support huge numbers of people. From a plate collision to modern civilization, it is all one connected story.
And that leaves us with one last big question. We've just seen how a single geologic event can send ripples through landforms, climate, and eventually life itself. So, if the Earth is this tightly woven, this interconnected, then our actions, the things we do, must also be creating ripples that we might not always see. The real challenge for us, then, is to start understanding those ripples and to figure out where they lead.